Since Montreal Protocol was so successful, let's see how Kigali is going to make it even better. This is just looking at the October average minimum ozone or Antarctica over time from 1960 to 2100. So this is the period of the ozone hole. The discovery happened in the 1970s, and then before the Montreal Protocol in 1987, there was great damage, and then it has recovered somewhat, but still not at the level of the 1960s in terms of the total ozone in Dobson units. And this is the image of Rwanda's Minister for the Environment, Vincent Biruta, making the Kigali Amendment official in 2011, I suppose. Is it? Okay. So, when was Kigali? We should look it up. Okay. Nonetheless, implementing the Kigali Amendment. So, many details here, but essentially it is about without any controls and with the controls that Kigali Amendment wants, as well as the phase out of HFCs in the developing countries by 2020, and we saw that already. And this is the HFC emission scenarios in terms of gigaton CO2 equivalent per year, taking into account the global warming potential as well. And because for temperature change you need to have that included. And this is the temperature change due to HFCs without any controls. So it's going to add to the scenarios from, so remember this is projection out to 2100. This is in addition to the emissions scenarios that have the so-called RCPs in the CMIP 5 and the CMIP 6 that will come out hopefully in 2021, right around the corner, and with controls from Kigali and phase out of HFCs in 2020. So the additional HFC contribution can be basically almost eliminated by phasing out HFCs. Already we are at the end of 2020, so we are obviously not phasing it out anytime soon. But Kigali obviously will help in reducing the contribution as well, especially compared to no controls. Okay, so like Montreal Protocol, this is going to be a good thing. The schedule of phase down under this Kigali amendment, looking at various groups of countries within the UNFCCC and Paris Agreement, A5 parties, group 1 and 2, so you can see the countries listed here. Non-Article 5 and Article 5 parties, so they are developed countries that will begin to phase down in 2019, and parties that are developing countries that are given additional time, and so on and so forth. Okay, so non-A5 parties and Group 1 and Group 2. Baseline scenarios, the time periods go from 2020 to 2022, 2024 to 2026, depends on which group you are in. This was already gone. This is also already gone. Okay, so freeze options. First step, 90%, 2032 90%, 2019 90%, 2020 95%, and so on and so forth. So Kigali has specific steps and phases compared to the baseline, and the final step is more important here. For each group by 2045 to 2030s to 2040s, it's going to be down to 20% or below. Okay, so that would be great in terms of the contribution here to global warming. But there is additional caveats in this whole thing, where the countries that have been given additional time out to 2030s and so on, developing countries. There are various options of jumping from, they went from CFCs to HCFC, and they will go to HFC, but they can just jump HFCs and go to the better options that we looked at in terms of the global warming potential, right? They are not in yet, they're not made available yet. It's not even clear when it will happen or how easy it will be for developing countries to have that option. But if Kigali works the way Montreal worked, remember we talked about before, Montreal was largely paid by US, Europe and Japan. Okay, so number of ACs, this is showing GDP per capita in this color here, and the countries on this axis, and ownership of air conditioners, percentage of households with air conditioners. Okay, what is the story? Obviously the rich countries have high number of households with air conditioners, whereas countries with lower per capita GDP have much lower households with air conditioners. Bad news, the projections all show that the numbers are going to increase as warming continues and pollution continues, because air conditioned air obviously gives you cleaner air in the rooms and houses. So projections of emissions for air cooling from electricity consumption in residential sector, just the residential sector, in terms of million tons of CO2. In 2017 it was here. Without any action, by 2050 it's going to more than double. Okay, actually more, almost triple, not quite, but 2.5 times. Okay, so the uncertainties remain in the energy efficiency of the new technologies in air cooling and the power mix. So how will the air conditioners be actually run? By renewables or fossil fuel energy or diesel generators or whatever and so on, right? And with strong decarbonization scenarios and energy efficiency scenarios, we can bring that emission of electricity consumption in air cooling quite a bit compared to baseline scenario, as well as compared to what happened in 2017. So that's the future. And the estimated annual emission abatement potential of air conditioner stock in 2030 for China and India and Indonesia are shown here for refrigerant transition, so HFCs to other options, and efficiency improvements, so shown again as gigaton CO2 equivalent per year. And you can see that efficiencies themselves can contribute quite a bit, but switching from HFCs to alternatives obviously can contribute quite a lot. And the contribution of emissions from China's Three Gorges Dam avoided here is about 0.1 gigaton CO2 equivalent per year. So there are many arguments made that increasing air conditioner efficiency is going to be one of the most critical things, much more important than reducing meat consumption or even afforestation of Amazon or recovering the lost vegetation, forest cover, and so on and so forth. Again, it's not either or, but just for comparison, contribution from reducing emissions from air conditioners is going to be a huge contribution to overall emissions reduction. So this is the contribution of India's national solar mission for emission abatement, but India can accomplish more from transitioning out of HFCs and improving efficiency of refrigeration, and same for Indonesia. Okay, so there is a global cooling prize now which focuses on residential cooling technology for all without warming the planet. So the problem is by 2030 over half of the world's population will live in hot climates with increasing exposure to potentially dangerous heat conditions. The cooling demand will boom 3 times globally and increase by 5 times in developing nations by 2050. And the mix of energy used in the developing countries is likely to be not as much renewables as in the developed countries. So this is an additional concern there as well in terms of electricity consumption for running air conditioners. At least 2.5 billion AC units will be in use globally by 2050, comparing to 900 million present, which was in some year which I don't have here. Only 14% of the maximum theoretical efficiency has been achieved by today's most advanced air conditioner technology. Only 14% of the maximum efficiency. So there isn't been much improvement in efficiency of air conditioners, which is why efficiency improvements can actually provide huge abatement options for emission reduction. So the solution is to spur residential cooling technology that has 5 times less climate impacts, uses 3.75 to 5 times less energy, and fulfills 7 other requirements, and so on. Is led by a coalition of global partners that engage industry and markets to identify and scale a solution. Awards at least US $3 million in prize money, US dollars. Initiates an era of transformation and global innovation in cooling industry. No kidding, if you can go from 14% to anything way above that, more than double, so 5x is going to be incredibly good improvement. And the impacts are going to be affordable access to cooling in parts of the world where it is becoming a critical need. Potential to mitigate 1 degree C warming by 2100. That is massive. If you are headed with business as usual to 4 degrees or about there, then 1 degree C is going to be a 25% reduction, which is quite important. Up to 3200 terawatt hour per year in avoided demand for energy, equal to the annual generation of electricity within the EU. Okay, entire EU's energy demand is going to be reduced. A cooling technology in billions of homes that has at least 5x less climate impact. So, long story short, Kigali amendment is great, but improving air conditioner efficiencies, reducing air conditioning, and increasing renewables to drive them is going to be a huge option and much better than many of the other mitigation abatement options we have. Everything has to go together, but this is much more powerful in terms of its potential to reduce emissions.